Sorry about that. Awesome. All right, let me get this going. It's kind of leaky. I'll show you what I mean. There we go. We're gonna let that marinate for a little bit. All right, this is a 180-degree magnet pulse motor, and we got a bunch of new components here. We got a 12-volt battery right here that is currently running this pulse motor. We got a 12-volt battery over here, which is running this one. So heck yeah, and this is this one right here. Awesome. Just need a few more components. This one will be solid. I love it though. So we're still on a steady acceleration phase. We're almost to 1200 RPMs. And then I'm going to kick on the booster engine. As soon as we I like to call it marinate, serenade. As soon as it like stops increasing in speed with the first engine, I'm going to throw the second engine. Alright, we're slowing up at 1300. Alright, I'm going to throw the switch. Oh man. Gotta throw it a little bit sooner because it's the bench power supply. There we go. It's my 1, 2, 3. So it should have been something like that. But you know, the bench didn't kick on, so Yeah, 2200, 2300. $2,600. Heck yeah, man. It's all good. So what are we trying to accomplish? I don't know, we're trying to light a light. We're just passing the time, really. We light the light successfully, but I have this motor over here that I've been like, I want it to run. I don't want it to like burst once and then stop. I want it to run. You know, I want it to run. I haven't been able to get it to run. So that's one thing I have on the docket. And that's 3,500 RPMs if we can get it to run. Without using a battery, a cap, or a power supply. We can use a cap as long as it's like in a cap train that starts on the pulse motor and ends at that motor. You know what I'm saying? Because I mean, I can just take my cat bank that I charged up, put it on the table, hook the two ends up, and it'll run. It should run, at least for a little while. But, you know, I think you need a speed controller. That would make sense. Little, almost like a pot, but simpler. So you hook up this in between that and the motor, and then you got a little speed dial, and that's cool. So how did I get here, and why am I doing this? Well, it's all about who I met. It's all about who I've met. Well, trying to do this. A lot of my earlier videos it's all permanent magnets. It's all about magnetism. It has nothing to do with electricity at all. In the beginning. And then I'm like, okay, how do I get my magnetic disc to spin on its own without me spinning it? And that's how all this started. So that's where my angle is. That's where it came from. And it's awesome. I'm like, yeah, now I can get my stuff to spin without me spinning it. Now we need to continue onward. I have still a vision in my mind of basically a magnetic sculpture. With your central disc, and then you got a disc on either side at 180 degrees, and then it shifts to 90, and it goes every 90, but it like spirals up because both ends are going at the same time. Yeah, I want to do that, but I want that to spin without, you know, it having to be spun. So again, you got to put the pulse motor in, and since there's a central disc, perfect place for a pulse motor. It's a brushless DC motor. I could explain the coils a little bit. It's an 18 gauge, 20 gauge, hooked into an SSG with a trigger strand of 32 gauge. What I mean by the 20 and the 18 are hooked into the SSG is that basically there's an end for the positive of the coil. I hooked both the 18 and the 20 to that end. And then I hooked the 18 and I just hooked it, both coils up to the same output of the SSG. And then the other coil, which I call the booster engine, it's virtually the same composition, except it's about half the size. So it's 18, 20, and 32. And the 20 and the 18 are in series due to the shortness. I blew one transistor, and I'm like, well, if I just put them together, it probably won't happen again, and I was right. So yeah, those two are together. Here they're in parallel. There they're in series, and it works out pretty well. I mean, you know, 2600 and barely any time. But this one over here is what I really want to get going with this over here. It's another 1, 2, 3. So it's virtually the simplest transistor circuit you can have that connects to a coil. You got your trigger that goes to the base, you've got your power that goes in the collector, and you got your connection to the coil, which comes out the emitter. Yes. See, as you can see, it's a little off balance once it gets going. So I don't know if I can, I mean, right now it's just a concept, but I've seen it a few other places on YouTube, this design, or like the format, basically. It all basically does the same thing. It's just the different ways that you put it together could be more or less efficient. So, and I'm trying everything, basically. That's what I do. That's what I've been doing. Yeah, if it doesn't kill me, I'm glad I tried it. If it doesn't kill me and it could kill me, I'm glad I tried it. Because, life is, I don't know, it's not, I wouldn't say it's boring. I would just say it's a different flavor when there's no danger. Because, I mean, surviving in the face of dangers rouses confidence in somebody, usually. Can't say that is for everybody, but when I win, and when the stakes are high, my confidence gets a boost. I love it, man. So I might make it lighter. That's what I'm gonna do. I'm gonna use different magnets and I'm gonna make it lighter. I'm probably gonna use ferrite. I got some nice ferrite magnets. I got 12 of them. So smooth. All right, now this one over here, like I said, it's leaky. Watch what I mean by that. See, it's like that. See, but now it's ready to go. See, it's working. It's working just fine now. But, you know, there is that one, because it's leaky. I mean, and there's enough voltage going through it to push the base open. The current pushes the base open. Or closed, I mean. Whatever connects the connector, the collector and the emitter is forced shut by the current. But you can make it stop. It's not, doesn't mean the transistor's blown. It just means that the way it's running at that point in time, because it'll go back to normal and you can use it. Yeah. All right, so I have big blue right here. I don't like how it goes over to the side like that. We got big blue right here. This is 32 gauge. It's 11,000 turns. I used to think that was a big deal, and then I heard about this other coil last night, and I was like, wow, man. You know, this coil got rolled on the machine, so it was easy to do. But you know, it's like half a three-pound roll of copper right here. Could be 13,000 turns. I'm not exactly sure, but the coil that I heard last night was very large in turn base. All right. So we'll put that there, and we're going to hook it up to this little apparatus right here, and it is going to get back EMF based on the way that the diode is in there. I think that's right. I might have to switch it, but no, I think that's right, because I had it the other way and it wouldn't function. All right, so I've had a very, like, almost a violent tremor since I was pretty young. So this is like me facing my challenge in the face and saying, ha ha, I can put that little ass wire in that little hole and you can't beat me. That's what I feel like saying. It's like, I win. Ha ha. Because it is, man. It's hard. Yes. Oh, yes, yes. All right, so this has two indicator lights saying that it's juicing up right now. They're turning red. Huh. I wonder. I wonder. Should we just hook it directly up to the cap bank? Maybe put a diode in there, but there's tons of diodes on that thing already. So, hello everybody, what's up? It's Papa Bale, and we're just taking a look at the pulse motor today. There are a few developments that I have. Something I said I'd never do. Well, it's amazing how people change. I got a soldering kit, and we're gonna get rid of the clips, man. If I need a clip, we're gonna change it up a little bit. We're gonna make them shorter. But all that, you know, it takes a lot of time and patience, and probably a plan would be good. But I have like no template. If you understand, like I know I gotta do stuff, but I really have no idea on how to get it done. Like if I have a template, I know how to use a template. All right, so and then we'll clip the multimeter to this bad boy just to make sure we're not, you know, in trouble. And then I need one more clip. We don't need a diode for the negative connection, just for the positive one. And I was wondering about SSG. Is there a part of SSG that is cold, like cold circuit? I don't know. I think like the flyback might be more cold than hot. But I don't know. I'm, you know, like I said, man, I'm coming from permanent magnets to wanting those permanent magnets to spin on their own. And that led me here. And this is all right for me. I'm learning all that I need to know to make what I want to have happen. Okay? And that's really all I need to do. I don't know, that's just my story. All right, let's see how much is in the cap bank right now. .4, 8.51. All right, so that's hooked up to this. Let's turn this on. Let's back this out a little bit. Because we wanted to get speed and then start genning, not start at all. That's not what we want. All right, it looks like we're flowing though from these caps to the cap bank. We haven't got any juice yet though on the multimeter, but I'm sure it's coming. This would not be an opportunity. very bad way to charge a cat bank. Yep, there we go. 8.52. This would be like, if you were making a list of like 5 ways to do it, this would be number 5. Maybe not even make the list. You know, it might not even make the list, but it is working. And then we're also lighting, it's basically a 100 watt light bulb. It's supposed to equivalent 1,000 watt metal halide, but it's an LED, so it's a 100 watt bulb. .853. And yeah, there, it's leveled off. Having that coil there prevents it from continuing to increase in speed, which it will do if I take that coil away. Yeah, so I can't wait to get my hands dirty with this. Oh yeah. I have absolutely no idea how to use this, and like I said, I have a violent tremor, so this is gonna be awesome. We're gonna you know, charge right through. Might not be the prettiest thing at the end, but yeah, so we got, from that little bit of time right there with the 2 magnet rotor, we got 0.05, 0.04 of a volt, which this is a 500,000 farad, I think. No, is it 500,000 micro? I think it's 500,000 micro. Maybe 500 farad. Farad. I don't really remember. It's one of those two. Anyway, that's cool. I love charging the cat bank in more exotic ways, you know, like not your typical way. And next we could just hook up the output of the SG . So we'll back that out and we'll look up. I think that will work. Yeah, that's not good. These were like the first. Oh no. Okay. Well, I'll make sure everything's good before I set it off here. There we go. We're already up to 875, me just doing this. Trying to screw with this thing. That's definitely not what I want. 9 volts. Yeah, this is just awesome. All right. Oh yeah, and then the generation mode, we are already halfway through 9. And it's not even like, there's definitely something wrong with the transistor, I'm imagining here. See, but that does nothing for the generation situation. All right, so, man, see, that's, I'm gonna hook it back up to the light and we'll see what happens. I got another plan here. See, it works just fine with the light on it. See, no violent jolting or anything from the coil. It's like, ugh. Didn't like being connected to the cap bank very much. But the camp bank is a whole volt higher than it was before I did all that. Alright, I'm gonna hook this thing back up again. Wow, those things are red. Holy cow. But the motor stopped a lot faster. And the fact that it's slow is kind of good for me because I like watching these things move, man. It's soothing. And it keeps me on my toes at the same time. Because none of it's perfect. See, now the lights are dim. That means it's hooked up. The energy's going somewhere, and it's got to be going into the cap bank. So that's awesome. Charged up the counter rotating pulse motor. Check that out just a little bit. Oh, I didn't realize, and it's like right in my face too. It's my fault. So I got 2 new SLA batteries. I'm running my stuff on them right now. I'm going to drain them like halfway. And then I'm going to use my nickel batteries to run the SSG. And I'm going to use the 2 SLAs as charge batteries. Yeah. Wow, man. My donut on my head here's got a bigger hole in it. The bagel. The funny bagel. So these 2 coils are coupled, and it's weird because this is like 333 turns of 18 gauge, 20 gauge, and 32 gauge. And this is like 222 turns of the same. This one's got to be a little bit tighter than this one is. Or this one's got to have a lot more than I say it does. Because I know this one's got 222. So this one actually might be 666. Because I know I did them like that. Different variations of 3, 6, and 9. And I tried to make all the coils the same composition except for the length. So like the same gauges. But each one was smaller than the one before it. Yeah, man, that's sweet. Been doing a little bit of work with solid state generators. I'm using these coils. These are equal coils. They're the same. Yeah, I gotta put a stopper in there or something. Something's gotta give. Maybe if I just move it, it'll flatten out. All right, so these two are 1500 turns of 20 gauge. And they're what I'm using for the base pulse. It's like okay, the energy that comes from the power supply. Well, this is what really happens. Okay, there's an iron core in here. Then I put this one on top of that. Okay, it's a Litz wire, 20 gauge coil with 26 trigger. I hook the trigger and the drive coil together in series because it's going to be a pickup coil. Then we shove this in the middle. See how it's sticking out? And then we put this on top like that. So the north is on the top and the south is on the bottom. You know, it's being sandwiched north-south. So that's good. And then we've got, I usually put big blue on the top. But anyway, this one right here, except for the core, the Litz wire is contactless with the bottom coil. And then I put a diode and I hook it to the next coil. So anything that's generated in the Litz coil will be driven into the next coil, along with whatever generation is gathered from this coil just being on top of the bottom coil. All right, I hope I'm not losing you. And then usually what I do is I put big blue on the top and I hook the multimeter to it. And whatever energy that we get off of that is energy that is propagated from the bottom to the top. And it might just be all coming off the bottom. It doesn't matter because the experiment is very loose. But I usually end up getting about 3 volts off of big blue, just contactless off the top of this. I get about 3 volts. And then what I do is I put it back into the bottom coil with a diode. And so it all loops, but it's, you know, it's solid state. So it's, you know, once it gets to what it's going to be, that's what it is. It's very easy to work with because it's not as fluctuating as, say, a motor or a pulse motor. It's, you know, 12.3 volts in is 12.3 volts in, and it doesn't like change. But this is, I think it's awesome. And then when we get the PWM and the MOSFETs in there, yeah, man, we can do 60 hertz, and I know exactly what 60 hertz sounds like. You know, I've been doing all different kinds of things. 45 hertz is, you know, 60 hertz is around the optimal, you know, resonant frequency for what I'm using. Funny enough. It's in between 55 and 60 at 12 volts. You know, at 12 volts, that's what it is. I'm just explaining the solid state drive right now. All right, and Litz wire generator coil. It's more of a 1-to-1 kind of because it's all 20 gauge. The Litz wire coil is made out of 20 gauge and 26 gauge, so It resonates already with the two drive coils by being the same gauge. So when you vibrate these coils at 60 hertz with an iron core, they're all going to sound the same. But I want to do it on my aluminum plate. Got so much stuff. It's awesome. All right. Aluminum plate. That's right. Now let me shift the camera a little bit. Wow, this thing is just in the way right now. Move it. All right. All right, so the iron core is in this one. And then we put the iron core down the center of that one. And then whatever's sticking up out the end, we put through some of this one. That's about all I got. That's all the iron I got. So it goes up about this far into this coil. But the initial generation and drive are full of iron. So that's awesome. Let me get some water. All right, so all right, so we got our PWM. And then we got our dual MOSFET trigger. Let me think here. See, I'm gonna run everything on these bad boys, and then I'm gonna charge up the bigger ones. You know what? this on a power supply, not a battery, because I don't have enough connects to hook up one of the speed things. So can't wait to get into soldering a little bit. That's going to be awesome. And it's probably going to be an uphill battle for me, but it'll clean up some space. All right, so now we got to get power to the MOSFETs, and then we hook the other end of the coil. I just need those wires to be separated, that's all. All right, here we go. I can show you guys the circuit if you want to see it, but it's really not that interesting. All right, and now, see, you got to put a minimum of 3 volts in to turn on the PWM. So that's where I like to start, is 3 volts in, and I can't do that with a battery that's 12 volts without hooking this up. And I probably could just screw all the ends in there, but I can't wrap my head around it right now. But that has always been a goal of mine. Now that I got a soldering gun, maybe I can make some of it happen. Yeah, these things tend to blow out pretty easily too. Let's see. So maybe not tonight, I don't know. I'm gonna try one more time here. There we go. Lights on. This is 369 right here. At 45%. All right, so we got our PWM. We got our power supply, 25 volts in, 100 milliamps. That's what you get with the big coils. Now, I haven't hooked up the generator yet, but I just wanted to show you the frequency output. You hear that humming? Right, okay, let's go 60. That's why I got the aluminum plate. 60 hertz. That sound familiar? 25 volts, 300 milliamps. That's awesome. All right, I'm gonna hook up the generator now, and we'll see what we're getting off of this. You can hear it humming. Sounds like one of those transformer boxes. There's one of those 4007 diodes. I have a bunch of those. Okay, so I'm gonna find out real quick. So this is gonna be, no, wait, we're gonna go here to here. We're gonna hook the trigger and the main drive together in the Litz coil. And then we're gonna probably should have done that first. We'll see if we're in the doghouse. That would suck. That's another thing that I'm learning as I go through as I'm doing this is patience. See, the patience would have been real good right then. But, you know, I'm aware that that would have been better to just shut all that down first. Oh yeah, damn. These little PWMs they don't have much, yeah, that's unfortunate. That's all right. I'm used to it. It sucks, but to say that even. Now I got other things that I can use, but nothing that's that good. I mean, I have a straight up signal generator that I can bust out of the closet. I think I might just do that. It's not there. Must be out here. There it is. Now let's see if I can hook this up. I'm really like not skilled with, but I think I can manage. So we're gonna go MPN. This would be an awesome time to bust out the soldering gun. All right. All right, now we need this. We'll go here. There. Oh man, that's a terrible clip. I'll throw this one away. Now,
I'm gonna put the light on there because I feel like having the light, it helps. Okay, and now the base connection. Yeah, I gotta get the soldering gun in action. Yeah, something's not right now with this whole setup. I can't put my finger on it, but I know that I'm gonna get another PWM, and the next time I set it up, it's gonna be a much more condensed circuit. Okay, so let's make sure we can salvage this transistor. Nice. All right. Twist those legs back. Sweet. Put it back in the box. Oh man. All right, here we go. Sweet. So I'm just thinking, how I had things set up. I'm going to take all this stuff back down because you see I busted out my little clips to put it all together. All right, so it's really easy to maintain, actually. But, you know, keeping it clean and maintaining it actually are two different things. I don't understand the question. Probably nothing that you've ever seen before. You've never seen it before. I can only say that I'm not making a weapon. Mm. This, however, is a 9-magnet pulse motor. It's being run on a 1-2-3 circuit. Thought I was going to say Bedini, but it's not a Bedini circuit. That motor over there is a Bedini circuit. This motor over here is not a Bedini circuit. Heck yeah, check that out. And for how heavy this thing is, it's pretty well balanced up until about, 1,000, 1,500 RPMs. I don't want to say it's my circuit. It's not my circuit. It's just a circuit that I use. It's the simplest transistor NPN circuit you can do, I'm pretty sure. That's a successful one. You got to put a light of some kind, either a 90-volt neon light or a 120-volt halogen light. It's got to have a filament. The light bulb's got to have a filament. I was trying to initiate my generator, but I tried hooking up too much stuff. I tried hooking up the multimeter, and all the 2 multimeter wires were underneath all the other wires, and I tried to jimmy it out of there with it running, and I blew my PWM. So my error. And don't try to do a bunch of stuff when it's on, because that's when everything goes to Now let's look at what I've done real quick. So far, I've demonstrated 2 motors. This motor over here has got a booster engine on it, and I can charge the cap bank with it. All right, let's do that for a second. So the Bedini SG motor circuit is this big coil right here, and the booster engine over here is a 1, 2, 3. So it goes base, collector, emitter, 1, 2, 3 connections. It's solid, solid. All right, I'm gonna take the. Must have totally missed them. I don't know. I don't know what to expect anymore. But it keeps me on my toes, that's for sure. All right, so here's the 2-magnet rotor. It's on off. So when they're 180, this one's on. When they're 180, that one's on, and then off, and so on and so forth. Now this big blue coil over there is charging the cap bank. But yeah, I thought about turning this one on its side, and it works. It performs pretty well. I just need to make a better stand for it. So what I was doing was putting different frequencies through these coils, seeing how much energy it would generate. 60 hertz is pretty resonant for what I'm doing. It's like the highest voltage output for what I'm doing. Maybe 55, 60, right around there. And yeah, like I don't understand um, what's so destructive. I don't understand. So you're gonna have to elaborate, and it's gonna have to be within my realm of understanding, and then I'll listen to you. I don't see anything wrong with what I'm doing. It's really just I'm just charging a cap bank, and when the cap bank is full, then my motor's going faster. Okay, then I use that energy to perpetuate speed because I like it. I want to go at least. I want to make a rotor that'll go 5,000. Right now I'm at 3,000. It's like my max 3,100 RPMs is my max. And that's because I turn it off because I don't want it to get outrageous. So yeah, I'm all ears, man. I'm willing to listen, but it can't be an opinion. That can't be an opinion that my stuff is destructive, because that's kind of like my stuff is most definitely not destructive unless I build it wrong. And then it can go flying across the room and really hurt somebody, but I've learned a lot. And even just adding something like tape really helps. Might look ugly, but those magnets aren't going anywhere. So cool. So what I'm working on doing right now is draining these batteries right here halfway. And then I'm going to hook up the SSG the way it was meant to be. Just look at that thing, man. The inertia alone on this is phenomenal. So cool. So, like I'll state again, the only reason that I'm doing pulse motors to begin with was I was doing permanent magnets uh, exclusively, and I wanted to make my discs that I was making spin, without me spinning them, and that's how I ended up here. Now I met a lot of people along the way, and they're like, "Yeah, this time travel, all that stuff," and yeah, maybe I don't know. I get stuff. Like I have a counter rotator over here, a counter rotating pulse motor. This is the stator for that. And as you can see in the middle there is a bearing, and that whole thing spins. I don't know why people hate that so much. I think it's one of the dopest things you can build with the pulse motor. It's not my, hey man, that hate, that's not like I don't get it. I'll never like get it, but yeah, man, I'll never understand why people don't like counter rotators. I mean, the only reason I may not like them is because you can't hook a standard meter up to them when they're running, because you'll stop it from working correctly. And seeing it's like a hint question. It's like, what are you trying to do? And I don't understand that question. I really don't. I don't really like try to do stuff necessarily. I just do it. And sometimes I break it, sometimes I don't. Ah man, I think this stuff is a lot less, has a lot less potential destruction than other stuff that I've seen. Much less. All right. Yeah, I better stop this because it likes to swing over to the side. As you can see, it's already working its way over. Now, the reason I'm using this rotor is the magnets are 40 millimeter by 20 millimeter neodymium M52s. I don't have to put any momentum into this to get it started. Just a nudge. That's all it needs. Move that coil out. We're going to do a little speed run. Where did I put my... And I'm sure the speed run would be way better with 4 magnets. I don't know why I think 4 is better than 2, but it just, for some reason, I feel like it's better than 2. Especially when there's 2 coils in play that are totally separate power. They're parallel coils. So 1032. Gonna let it get up to like 13. 1285. 1160, 75. Okay, so 1200 right now. All right, we'll throw it on now. Oh, it's not. Damn it. It might even be beneficial to start. There we go. I gotta remember to start the little one first. That's not the way I wanted it to be, but with having the little one hooked up to this power supply, it doesn't like to turn on when it's going real fast. Two magnet rotor. $2,500. 26, 27. And that's still pretty stable. I'm just gonna shut it down. 2,700 RPMs. Not too shabby, but like again, not the best. I want to be about 5,000 RPMs. So I'll need to make an even more balanced rotor. This is what I've done. I've lowered the center of gravity so the pole won't shake due to top heaviness. I've lowered the center of gravity. I put the pole all the way through this table. See it? But one like when it's going 2,700 RPMs, one like just very small can like destroy the whole thing. And I got a souvenir from when something like that happened. And I love moving parts, man. I think it's a whole nother challenge. And so, I subscribe and join certain channels so that I can enrich myself. Okay? That's why I join channels, so that I can enrich my life. And it sucks. I mean, money right there, man. Money is your best friend. The lack of money is the root of all evil. If you don't have any money, you'll understand what I'm talking about. It's the lack of money. You know why you're doing the evil deed for the rich guys? Because you don't have any money. So yeah, just get yourself squared away. Maybe some for your kids if you decide to procreate. All your loved ones come next. You, your kids, then your loved ones. And yeah, you should have enough to help out spontaneously if you feel the need to. But you need to keep your priorities straight when it comes to money. I try not to let anybody tell me that those shouldn't be my priorities. Me, myself, and I, then my kids, then my loved ones. And you always got to have your spontaneous stash. It doesn't have to be a big stash, but it should, you're going to love being that guy that has that $20 bill that some other guy needs. One day you're going to like being that guy. Yeah, and as for practical uses, you should name a few of those practical uses. Instead of just saying there's a number of practical uses, you should say a few of those practical uses. And I think we all know what I'm talking about. Yeah, man. I mean, whatever. One tragedy after another. Jeez. No, and I totally 100% agree to a man and a woman's right to defend their home. But as for being a hero, I think you need to know the whole story before you just go randomly shooting people that you think are doing bad things. You know what I'm saying? So, like, what I'm trying to say is the concealed license permit. I don't know how I feel about that. I feel that a man should have a right to have a gun in his home to protect him and his. But, you know, I've never had a problem, really. So I don't understand the other half of it. I just don't get it. And yeah, there's a lot of hypotheticals, and for your hypotheticals, okay. But I mean, seriously, accidents, accountability, man, that's what it's all about. And I'm not talking about self-defense. That's not what I'm talking about. I mean, people come into my channel and they're like, hey, man, you're building a bomb. So let's talk about it for a second. No, I'm not trying to build a weapon. Like right here in my what are you trying to do? No, I'm not trying to build a bomb. Okay. Yeah, there's just so much that I don't understand, uh, like the reason for, and that's okay. I'll learn. I'll read up on it. But you know, my opinion as of right now is that even you know mistakes. It was dark. Whatever, dude. You you deserve to pay for your mistakes. That's all I'm saying. Just like me, I deserve to pay for my mistakes. That's why I try not to make really big ones. And whether you think it's a mistake or not really doesn't matter. Seriously, that's the. And people love to argue just for the sake of arguing, and they bring up points of contention that have absolutely no context whatsoever as to what the conversation is about, thinking that they have, you know, and they're like, yeah, well, we're against you, and this is why, and it's like, okay, whatever. Yeah, are you sure you're in the right place? I don't know. I don't know anything about what I like as much as I would like to know, but I do know that like all my friends carry weapons, and I guess it's a not only is it like a privilege to have a permit, but it's also like another level of growing up. Like, it's another level of maturity. Because you really do have to pay. Like, if you shoot somebody on accident for any reason, you have to pay for that. I don't know. I see a lot of possible accidents happening just recently all over the place. Me, personally, I don't like guns. I don't care if people carry guns. I think that the rights are the rights are the rights are the rights. There's a lot of parts about it that I don't understand. Um, but more, it's, it's the way we had it. I think a lot of it's been blown way out of the deep end, but as for, the right to bear arms, yes, absolutely. Me personally, I don't think I'll ever do that. But what about you? Mm. So voila, the magnetic disc moves on its own, and we are on to the next phase. What's the next phase? Having a lot of these discs move in sync in a specific way. So there's going to be three. There's going to be one in the center, and then there's going to be two at 180 that are exactly the same as this. Now I might actually make this a 12, and then make these two 6s, and then have this be alternating north south, and have this one be north and this one be south. So that way, when it's only hitting, there's not double magnetism on the middle. You get what I'm trying to say? Because if both of these rotors on the side are sucking on this thing at the same time, it's not going to spin. But if you do north over here and south over here, then it's every other, and it'll work. And I came in peace. I did. I came in peace, and it wasn't what people were interested in. Wow, those little cups. I'm getting a strong breeze off this. I get a kick out of the parallel drive circuit, man. That's awesome. It's an on-off situation here, so when this one's on, that one's off. When this one's on, this one's off. So that's awesome. And then I could move it to the 180, and then they'll both hit at the same time, and that's powerful too. That's also very powerful. I mean, of all the stuff that's out there that is destructive, I think me being in my bedroom playing around with magnets and electricity is the least of people's worries. And it's all right because I know the truth. So, I mean, whatever happens, I know my truth. That is something that they can't take away from you, that you know exactly what you did. You know exactly what happened. This is the only way to embrace that is to not be connected to anybody or anything. And that, unfortunately, I cannot say. I am not that free. I cannot say that I'm not connected to anybody. I love people very much. I love that sound. That's the 1, 2, 3 sound. Wow, that's very different. That's very sturdy compared to what it usually is. Awesome. The only problem is that it scoots to the left. So the inertia and the weight, actually, and the inertia of this rotor is immense. It's 9 magnets, so it's 40 degrees of separation. I believe it tumbles, say, better than an 8 or a 10. That is awesome. Can't wait to get that stabilized. And I'm wondering, like, how I would generate off this. I'd have to have either a trifilar coil or an SG circuit. Those are the only 2 ways that I currently know to generate at any significant rate of speed. That would be so cool. There we go. Boom. All right. See, like an opinion, for example, just let's explore opinion for a minute. Where I'm from, it is a custom for you to have an education supporting your opinion. Or at least, if not an education, a strong vocabulary to support your opinion. The more specific you are, the more like people you will reach with your opinion. The more vague you are, I don't know, man. I don't understand vague opinions. They're designed to instigate. Well, it's all right. It's still moving, but it's all right. And it's not like you don't have a right to have an opinion. It's not like you need an education to have an opinion. But the more you know about what you're having an opinion on, the better off things will be for you and whoever you're trying to convey your message to. But I mean, just being vague to begin with is, the first question is, well, what does he mean by that? Or what does she mean by that? And I mean, we all know where it's going because it's really just a, what do you call it? A pussy move. It really is, and it's like instigating, and it's being a chicken. It's best you just don't say anything at all at that point, right? Because you want to instigate, and yeah, I don't know, man. Some people's kids. I am that person 12% of the time. That person that I don't like, I'm him 12% of the time. And that's cool. My world is very small. So if that number is good with me, that number is going to improve my life, quality of life greatly. Because it truly is that's what it is. Know thyself, right? The old adage from the Matrix, know thyself. I guess it's Latin, so it's from Rome. And I don't know. I consider myself somewhat blessed and somewhat damned for having learned the way that I have, because other people are just expect me to know what's going on. I have no idea what they're even thinking. And I'm like, okay, am I doing something that's wrong or you don't like? You just got to remember that just because you don't like it doesn't mean it's wrong. And yeah, I just, whew, that's going. Look at that. So we put that load on the rotor and it smooths itself out. Stops accelerating and it just smooths out. That's awesome. But I think it'll pick up again once it gets used to this. So again, the objective here is to reduce the batteries to about halfway and hook them up on the output of the SG and use my other 12-volt batteries to run the SG. And then we'll do some battery swapping. And no, you don't have to explain yourself to me. Just stop talking about what I'm doing. Then you don't have to explain anything to me. Or you can go ahead and you can talk about it all you want, but I don't have to explain myself to you, is basically what I'm really saying. But for those of you who are really interested in this and like interested in what I'm doing, I'm just making the disc move without me actually moving it. That's the whole point. That is the purpose. Yeah, I want to get something probably for my next live. I'm going to show you all the stuff that I started out with, and you'll probably get a better idea of why this is where I'm at instead of, playing with plasma. That's not where I came from. I don't have any education of any kind in electronics. I love magnets and magnetism, but I'm very passionate about magnetism. Okay, it's not electricity that I'm passionate about. And I mean, I got tons of ferrite magnets over here that I've been, using to maybe And I'm not looking for it to start up on its own. I'm not looking for it to run forever. I'm just looking for it to see if it will help or hinder at certain speeds, at certain placements. I'm not crazy. I'm not trying to do something that I'm not chasing a rainbow. Okay. That's not what I do. Now, there's a lot of real stuff out there, and I kind of want to, that's why I got the soldering kit. I want to narrow it all down. I want to learn ZVS. I want to learn Slayer. I want to learn all that stuff. It's not like, and refine what I'm doing now, you know, so it's not so amazed like this, you know. I get that. You're not the only people who don't like that. I don't like that either. You think I like that? I just don't have options right now. I mean, I just got the soldering gun. And yeah, for those of you who've been with me since the start, I don't know if you're all, any of you are still here. It's been a journey. It's been a trip. Lots of failures, lots of successes, lots of step ups and ingenuity. Like as you can see, the magnets I used to like make the rotor with the holes in the side here, and then I glued them in. One of them actually popped out, so I ended up this one right here. You can see that it's still popping out. But I put the tape around it, and it's no problem since then. I think I'm going to glue that one back in there though, and then put the tape back on it, so that because it forces its way out of the hole and stretches out the tape, so you can see it kind of stretched out the tape from the force of inertia. We're going to try and get rid of all those problems. But that's the old way of doing it. This is a newer way of doing it for the radial design. Gravity plays a huge role here. You can also put a toroid on the bottom, which will hold all the magnets in place as well. But you got to center that thing like really, really good, or it's a hindrance. Anyway, I think the gravity is quite enough. Gravity and inertia keep those magnets in place. And take a really weird physics to make those pop out. Weird physics. And anyway, that's what I'm talking about. From like rotors that are dangerous to rotors that are not so dangerous. And it's really just a simple design switch. See, so this is a idea of what the sculpture is going to look like. You got your base, and then you elevate one level, and you get it so the magnets will interact on vertical. Close enough that they'll interact on a vertical. But I think like 12 in the middle, and then 6 on each side. I think that's what I'm going to do. I think I've been there before, actually. So like one of my videos from maybe a few months ago, I had 12 north-south in the middle, and then 6 north on this side and 6 south on that side. And it worked seamlessly with a pulse motor. So it worked at speed seamlessly. So I'm going to reenact that. I'm going to have to get the right rotors or make new rotors. And I think I'm going to use the flat magnets instead of the cube magnets. So you saw me spin it the other way, it didn't work. But you can hear that magnet. See, it's just one magnet that is loose in there. I mean, it really throws it off, but I'm going to glue it back in. I found my glue, so I feel good about that. All right, so those are going to be the dry batteries. Little battery pack right there. And charge batteries. I just wanted to be able to charge for a little while and not, blow up before I run it for a little bit. And I don't know what SLA batteries do when they get too hot, but probably just shut down, I would hope. There's the SSG that I've been talking about. And that's that sound that I'm talking about. And I think it's all because it's on a slant or something like that. But yeah, like when I when I put it together, it'll be flat. I just like to show you what I'm working on, that's all. I think this might actually be something that I'll complete though. That'll be fun. And that's radial design. I got an axial flux rotor over here on the ground for the same setup. All right, I'm gonna see where we are with the cap bank. .88 volts. It's not even up to 10 yet. Okay. I want it to be at least 12 before I flip it and use it to power something. So many fun ideas. Hmm. All right, let's see with like a full copper load on there. What are we working with? 21, 19, 13. 18. Okay, there we go. There's the load. Got it right up next to it. Let's see where it slows down at. Still going down, 14.95. Here we go. Just need to put that load on it and everything makes sense after that. 13, 61, 53, 46, 34, 1300. So is this a way that I would recommend that you charge your cap bank? No. But if you don't have an SSG or you don't like have know-how about the collector on a transistor, this is another way to do it. $10.27. Wow, that thing just it's going to stall it out. Ooh-wee. It's going to stop it. And I that's why I put it up in there like real close. 900. 800. Yeah, I had a feeling it was going to stall all the way out. But let's find out if that's what it's going to do. Because I think not only is the coil, see, I got a Shatsky diode connecting the two ends of the coil to itself. That is happening. And then I've got the cap bank connected to the other end of this thing. That's double load. Oh my God, is it going to stop? I think it's going to stop all the way. It's going to stop. 450. $995, almost 10 volts, stacked up in the cap bank of like less than efficient way. That's a lot of bolts in the cap bank. Oh, I think we're leveling out. 400. Oh, we're still going down. Oh, leveling out. We're leveled out. 400 is our level mark. So that's a dual drive being virtually swamped down by this coil right here. And the cap bank. It's all sucking the life out of the pulse motor. But this is good, man. 400 RPMs with that load. Man, that's awesome. Wish it could go a little faster though, but it's a 12-volt battery for the one. I can make the other one go faster. Nope. Heck yeah, man. All right, so I think that's going to wrap it up for me today. Really appreciate everybody hanging out. Thank you very much. Peace out. Have a wonderful night. Bye now.